Okay, can you hear me okay?
Yes, I can hear you. Yeah.
Okay. I have a question. Can you allow me to share my screen?
Oh, you want to share screen? Okay, no.
Yeah, I have a question.
Just wait. I enable you now.
Okay.
Yeah, you can share screen now.
Okay. So I was a little confused. I was working on the homework,
Mm-hmm.
and in um the homework it says to create a Python program about the data for credit card example, um and then obtain the confusion matrix and calculate the accuracy. But there were a couple of additional files that you had added to the zip file. So my question is, well, actually, hold on one second. Let me share my entire screen.
Mm-hmm.
Share. So my question is, in doing the homework, are we only supposed to do the credit card example? Or let me see. There were these different files that you had in there, the accidents file, and then there was one other file that you had. So my question is, did you want us to do the credit card example for the homework and then go back and run the analysis for the other files that you attach? Or for the homework, you only want us to do this credit card example that you have here? Does that make sense or no?
Uh, your question is that mm,
In the code that you provided to us, it had the code so that we would run. Let me change here. It had the code so that we would run the other files that you provided to us. So it was this accidents,
I see them. Okay.
yeah, accidents in file, and it was one other file. Now this one is my file that I created for that credit card example.
Yeah,
But
yeah.
when I used the code, it had other stuff in it, with the other CSV files that you have. So my question is, to complete the homework, do you only want us to do the analysis on this credit card information, which is wait a minute.
Yeah, you're right. Just only the
Yeah.
credit card.
Okay, so those other files that you had, we don't have to do any analysis on those other files, just this example that's here, right?
Yeah, yes.
Okay. And so what you want us to do is to basically have a Python program to work through a neural network. And then you want us to obtain the confusion matrix and calculate it for this data here,
Yeah,
correct?
yes.
Okay. All right. That's what I was confused. So I just wanted to clarify.
Yeah, okay. I'm
Okay. Thank you.
checking.
Hmm.
Yes, the CSV file in Zapier. Yeah,
Yeah.
yeah,
Yeah.
it's in a file name. There's a neural network lab CSV.
Yeah. The CSV files that you attached,
Mm,
it did not correlate to that credit card data that you have.
oh,
Um, well, I'm sorry, let me back up. So you did have that data, but the code that you have didn't pull in the credit card data. It had those other files, which I assume that maybe you pulled in the other files so we can at least see how
mm,
it runs and how it looks. But I was just a little confused because I
okay.
didn't know if you also wanted us to do the other files as well, but it sounds like you didn't or you don't.
I check the video reference, what I did. Maybe I overlooked something.
No, no, no. I just wanted to clarify because I had to, work on, and catch up on your homework and stuff. And I was just confused on my end. I can go back and
Yeah,
look
can
at
you
the
share
video.
your screen with your code? So I check
Um,
whether.
yeah,
Yeah.
hold on. Now I started to change stuff, so um All right. Let me go back here. Okay. Yeah, because I worked on multiple things. So what I did here, this where it says
Yeah.
neural networks that's what I call my file.
Yeah,
And the predictors, that was something completely different because it pulled in a different file. So I changed my predictors to years and
yes, you're right.
salary, and then the outcome was use credit.
Yeah,
And so, I ran the analysis there. So then for the other code that was here, that's when I plug in my other file as well. Because like I said, I was a little confused and I'm like, well, let me just see what this will have. So I was playing around with this second section here, right? And I got errors. So I'm like, well, let me go back and look at those. So then there's another section, the class probabilities. And now this pulls in the file that you had provided to us. And I hadn't quite worked through that yet, but I
yeah, it's
see.
different files. They are different files. I think
Correct.
the first one is correct. First,
Mm-hmm.
yeah, first, yeah, this is correct.
Okay. Okay. So I'll just use that.
The problem is that the arrow is very large. You may can you change the the number, the middle layer node number?
The middle layer, you talking about this right here?
Okay, I check.
Hidden layer intercepts.
Not here. Maybe can you scroll up?
Yeah, uh-huh.
Structure of the neural network.
Okay,
Okay,
so this is
layer
at the top.
is 3. You 3.
Mm-hmm.
Change it. Okay, what I check my code.
And I'm sorry, I didn't want to just jump in on top of class. So we can always talk about it at the end because I didn't want to interrupt what you have planned
Can you
either.
increase the 3
Mm-hmm.
to about 6
Okay.
in the run again? Yeah.
Yep. Mm-hmm.
What's the performance?
Yeah, okay. Yeah, right here. Okay. Yep. So I reran it. Let me.
Yeah, continue run. Yeah. Yeah, this is 100%.
Mm-hmm. Okay.
Now it's better.
All right.
Mm.
So I'll just.
Yeah, you already complete at the table 11.3. You already complete it.
Okay. All
Mm.
right. So I don't need the information at the bottom
The
since.
others not related.
Got it. Okay.
Mm.
Thank you for clarifying that for me.
Yeah, I see I create a video.
Yeah, I'll go back and look at it because I had to work on another assignment for you as well that I turned in, and then test and this, that, and the third. And so I got to this a little bit later, and I'm like, oh gosh, I just didn't get a chance to ask you about it. So that was my error. Mm-hmm. But I'll go back and double check the video as well. Thank you, Dr. Wayne.
Okay, yeah, you're welcome.
Mm-hmm.
I'm checking my history. So this is 17. Should be that one. Four.
Okay. Oh, okay, well, it's fine, as long as what I'm doing is correct. I just wanted to make sure I wasn't materially off. Okay, that's fine.
Yeah, just
I can go through this. I'll just save this version.
maybe your computer. Yeah, okay, I just show
You did, oh, wait, okay. Oh, yeah, okay. I don't think I saved that version then. Oh, so I need to go back and look at that. Okay. Thank you, Dr. Wayne. I'll go back and take a look because you're right. That was my voice. I definitely asked the question. I don't think I saved that version. So I don't know what I had going on, but thank you.
You're welcome. Yeah,
Right.
so is the forget what I changed.
So what, like a minute and 45 seconds? I can go back to that point.
Yeah, this review.
Okay.
Which one for the code ID? Maybe it's 31.
That was 331?
Yeah, maybe 331.
Okay, okay.
Oh, I didn't share screen. Okay, I didn't share screen.
Oh, you
Oh,
didn't? Oh, okay.
Into Excel.
Yeah,
So
31.
you can see, you can
Oh, I see. 331. Okay.
three and three. Using fit function, then make prediction on all the data. Then we
Yeah,
for
31.
okay, we output the intercept
Got it. Okay.
for the assignment. We output the outcome.
So now it's 100.
Output the computer matrix. Yeah, then we try different methods. Okay, these three can use relation between two.
Yeah, hard layer. Now 5. I use 5.
Okay.
You use 100%.
Yeah, do you have any questions?
Yeah. Next one, share the video of 330.
331. Got it.
Yeah,
All right. Thank you.
31. Yeah, so 31. Okay. Yeah. Yeah, I updated the document for the test money. And you can check the I add one quiz for the test money. You can take it this week. Deadline set the 28th. You have 1 week to complete it. We can review a little about the questions. Okay, you can open this. That's my name. Questions. Yeah, we review questions. Yeah, for the question in a test, what is the each word preceded and followed by? This is the delimiter. Yeah, because in a tokenization, we analyze the whole text and separate the terms using the delimiter.
Dr. Wang, are you saying something because you're on mute?
Oh, sorry.
Oh, that's okay.
Yeah. Oh, actually, this is the review for the previous one module, test mining.
Mm-hmm.
Sorry about this. Okay, actually, this first one, questions. Yeah, in
Mm-hmm.
the test, what is the word preceded or followed by?
Did you say that was the delimiter?
Yeah, delimiter, yes.
Okay.
The next one, in a spreadsheet model of test, what is row, column, and a cell?
Shoot. Let's see here. Let me see.
Okay. The spreadsheet model of test, just like the figure in the bottom. Yeah, the column will be different terms in the text. And then row will be the different document, different sentence. In the cell, different element will be the presence or absence of the terms in the document or text.
Okay.
Yeah. This is the solution. Okay, next one, questions. Yeah, what is called for the process by which you identify delimiters and use them to separate terms for this process.
Wait a minute.
Yeah, this is tokenization. Tokenization is to derive the terms.
Okay,
Delimiters.
tokenization, okay.
Tokenization. Next one, what is called for reducing multiple variants of a word to a common core.
That's not pre-processing, is it?
Yeah, this is
Pre-processing, okay.
processing, and this will be stemming. Stemming, because this will reduce a different format of one word into one format, one call. That is stemming. And here, a stemming reduce different variants.
Okay.
Traveling, traveled, just using Y to represent travel. Yeah, the stemming. And the previous one, tokenization,
Mhm.
identify delimiter, then separate terms. We get different terms. Then, based on tokenization, we use stemming to reduce the number of terms. Yeah. Then we will remove some terms, just inside the stop list or the length, just one or two, and less one or two. So can you realize this pre-processing? Then we can use the frequency to replace the business or offsets, and use the normalization. We will not use the detail email address, URL. You just use one normal term to brief that down. Okay, so we complete this question. Next one questions. In what kind of documents can frequency filters can filter eliminate terms that appear?
And
Frequency
these
filter.
numbers they exclude Project Spring. They do not have Project Spring, okay? Now, what my team was supposed to do is simply add Project Spring to these numbers, okay? So
So, okay, what's your suggestion? And what kind of document frequency filter element term that appear? The frequency filter can remove the terms in almost all documents, or almost does not appear. Yeah, two situations. So we can check the original document here. Yeah, frequency filter. Nearly all appear in all document or non-document. Yes, there's too frequently appear or too less frequently. So we can remove these two kind of the terms using frequency filter. Okay, next, what is called? Sorry. Next, in the testimony, what is the goal of pre-processing? Yeah, the goal of the pre-processing is to reduce the number of terms into the meaningful words. Okay. Yeah, the goal is reduction of the text, vocabulary reduction, without losing meaning or predictive power. So that's to transform the text to the terms and using the stemming to reduce the number of terms and keep the meaning, will not change the meaning of the original document. Okay, next the question is what is TF-RDF? Where a rare term is present or frequent in a document. For a term is frequent in a document, the TF-RDF value is high. Yeah, next one, what is TF-RDF? Is where term absent from document or abundant across all documents. The term not appear, the absent or appear all document. That means that term is can be deleted. Yeah, can be omitted. So the TF-RDF value is low, almost zero. The next one, what maps multiple terms to a small set of concepts? So this. We can using the principal component analysis to map multiple terms to a small set of concepts. So we reduce the number of terms and transform the terms to concepts. So here, so all this will be the latent semantic indexing. So it maps multiple terms to small concepts. The latent semantic indexing. It's based on the similar process of the principal component analysis. Okay, next one is the matching for the concepts. The TF is the term frequency, the abbreviation of term frequency will be here, frequency of term. The RDF will be the RDF will be inverse. Frequency inverse of document frequency. So let's check. Okay, let's continue. The IDF. IDF will be in a slide. Yeah, IDF here is the inverse document frequency. TF is the term frequency. You can also say the IDF is the log of the inverse of the document frequency, with which document have that term. Okay, latent semantic indexing. This is actually to mapping multiple terms to a set of concepts. Okay, the tokenization is to derive the terms using the delimiter will be here. Stemming to reduce multiple variants into core. Okay, this is the questions we discussed last one module, test mining. So you can take it before next Monday. We continue next one, 11. Is the social network analysis. You can open this document. So I own. This one lecture very easy, very simple. We just use several simple function to realize the plot of the relational concepts. The social network analysis is very popular in Facebook, in LinkedIn website, Twitter, etc. So we can build the relationship between the users, different targets. We have two kinds of networks. The first one is unidirectional network. Just like a left one figure. We have different users, John, Jenny, Dave, Peter, and we have connection between each other. And there's no direction, there's no arrow for the link. Okay, the next one is a directional network. It has a start point and end point from right one figure. From which we can see the dependency between two users. So the one follow the other one. The on-directional will be for the representation of the friendship between the users. And we can assign the weight for the edge using the thickness to reflect the strength of the relationship. It can be for the number of the communications, value, or number of transactions. Just like the left one figure, using the wider or thick edge to represent the strong relationship. And in this edge weighting, the coordinate has no meaningful information. Yeah, so the most important information will be the connection, the link, and the thickness and the duration. The coordinates does not matter. For the right one figure, the left side is equivalent to the right side one. Even though they have different shape, actually they are the same. So the coordinate does not matter. This one slide for the principles of the layout one figure. In the layout, every node should be visible. And for every node, you should be able to count its degree. And the degree will be the connection. And for every link, you should be able to follow from source to the destination. So it has the arrow for the directional link. Clusters and outliers should be identifiable. Yeah. So we have this example. To represent the relations between relations between two users. Okay. This is from the Twitter graph. The left side is for the origin user. The right side is the destination user. Okay, we can replace using the list. List of the username using this table. We can also represent using the adjacency matrix on the right side. Will be the row, the different row columns will be different users, and the different rows also will the different column will be the destination. Different rows will be different origins. So we can represent the directional link Dave from Peter, or Dave Peter, and Dave to Jenny and John, and then Peter to Jenny, yeah, Jenny here to Sam. Peter to John. Yeah, so this will be as a partial information. Yeah, so you can translate from adjacency list to adjacency matrix. We will discuss several terms in this one model. The edge weight will be the strength of the relationship. the path will be from one node to the other one node. This one route from one node to the other one node. A connected network, that means every one node has a path to all other nodes. Yeah, so every node is connected to the network. The next one, click. Every node directly connected by single edge to each other. Yeah, each node directly connected by single edge to each other. So click. The next one, singleton, unconnected node. Only one node in the network. A degree will be number of connections to one node. Centrality is the average path length to other nodes. Between this is extent to which a node is on the shortest path between other nodes. Eigenvector centrality is a links to other highly connected nodes. Weighted more. Egocentric network, the network around a single node. So just have definition above. Okay, next concept, degree distribution is the distribution of number of connections per nodes, a density ratio of number of edges to maximum possible number of edges. So the left one figure is one dense network, is density, high density network, because the number edge for one root for one node is about 1, 2, 3, 4, yeah, divided by all the edges. Yeah, the density. This is very high. And the right side, very low, just 1 to divide by all the nodes. So it's a very low value for the density. So it's the sparse network. The sparse network, that one is a dense network. And this is for the link prediction. Link prediction is to make a prediction on the next link to form in a network. The first step is for each node and score similarity to all other nodes. The second step, make a traditional predictive model variables to calculate similarity. Okay, the first step, make a network matrix. Yeah, for example, the shortest path. The fourth step, the unlinked pair with the highest similarity score is the predicted next link. So you can realize the prediction over the next link. Here we have 2 examples. One is the new customer order online. The other one is cell phone number. Linked to known territories. Terrorists. And we can use the data in the table. Yeah, for the analysis. Yeah, in the example of the new customer orders online, we make analysis whether the new user already in a customer database or not. Now for the cell phone number, we can analyze whether it is linked to the known terrorists, and whether this owner is the same person as a suspected one in the partner intelligence service. Here we have the example code. We have the the array. Yeah. There are two columns. Yeah, from the source, left is source, right side is destination. So we have multiple relations. Then we call the function from pandas edge list. Use this data and also define the source and the destination. Then we can draw this plots. Yeah, this will be the below figure. So this is the relational yeah, edge connected using the link between the relations between two users in the relationship. Okay, the other one plot is to use the different parameter for the create using. And here we use the DI graph. So this will use the directional link. The previous one is the undirectional link. It does not use the default parameter for the graph. Here we use the directional graph. So we can obtain the figure like this. So it has a directional link between the users. Okay, that's all. Do you have any questions?
No, not at this time.
Yeah. Yeah, we can review the code now.
This slide
Okay.
will be updated.
Okay. So we can start Anaconda. Yeah, we already completed the 11 modules. Yeah, do you want to review other modules? Actually, from the textbook, we have a lot other models. Yeah, if you are interested in, we can continue the others. We still have 1 week available for this semester. So will be next week. Then will be the exam week.
While that's coming up, I don't think it lists our exam. So when you go through the code, can you talk through the exam once you finish with the code?
Exam, which exam?
Are we gonna have an end of semester exam or no?
We have the final exam. This will cover 8.
It's still gonna be that negative
Mhm.
12.8, not the negative 9.8 that's in the table that I just sent. Do you
See, I mute him. I mute him. Okay. So 764. So I download the social network analysis. Download this one. And then we open this and I check. I check the code. All right. Drop data. Okay. Okay, social network analysis. So and run. Yeah, so it created the on-directional graph. Yeah, for the connections from the list of the connections. And we added the options for the directional graph. So we'll plot using the arrow. So a little different with above. And the next one for the draft CSV file. We call the from pandas edge list. So we can open the draft file. Draft has multiple fields, entity, rated entity, and a relationship, description, and address. So you can load data using two fields, entity and a rated entity. So just use the previous two columns to build the graph. The first one use the eigenvector centrality graph. Yeah, so you can see, you can use the size of the nodes to represent the centrality. The bigger size has more connections. Okay, next one. Just continue on the previous one data. For the DF original data from matrix source and from a tool for the source and destination of the users. So we plot the connections. Now on the left, we can make that one connection plot. And by the way, draw with different formula. The first one use a circular plot. The second is the Hamada Carvey plot. Actually, they are equivalent. So the coordinates do not matter. And this one, we plot a centrality. Okay, the centrality message and between this message and the eigenvector centrality message. This is for the angle graph using a different radius. Left one using the radius default value. Right side use the radius 2. Then we continue the others. Yeah, that is not covered in the lecture, but you can review by yourself if you are interested. We just focus on the relational, the social network plot. Just using the data, the source and destination make a plot. The on-directional plot or directional plot. And you can also make the eigenvector saturated plot. Yeah, do you have any questions?
No, I don't.
Yeah, because this we finished 11 modules already. We still have 1 week left in this semester.
Mm-hmm.
Will you continue to review other modules? Yeah, we have the final exam covering module 8, 9, 10, and 11. The exam will be in the exam week,
Mm-hmm.
from the May 5 to May 9.
Okay.
Yeah, we have exam here. Because we, this week we finish exam 2. The last exam will be from 2 weeks later.
Okay. So really next Monday night is our last class, right?
Yeah.
Okay.
Do you want to review more new modules, or just stop here?
Are you asking or or are you telling us? Are you asking us a question?
Yeah, ask you questions. Do you want to review more modules?
I mean, I'm okay if you want to review
Mhm.
more. I mean, you can poll others, but I mean, I'm okay if you wanted to review more material. You talking about tonight, right?
Yeah. Okay. Well, we add that one module. I will look for more interesting module. Maybe you can use this in your research.
Yes. Okay.
Yeah. Let me check what others. Hmm. Yeah, we maybe we can try this combining method.
Okay,
Yeah, I will let you know before the class. Maybe, yeah, we still compare the discriminant analysis or combining methods. Yeah, we will not use this for the exam, just for review discussion. Yeah, do you have any questions? Maybe you can, with this discussion, just stop here.
okay. No, me personally, I asked my questions at the beginning, with the neural networks code. So for me, I think I'm all set.
Okay. Is there any questions from other students?
No questions for me.
Okay, thank you. Salisha, do you have
Me
que-
neither.
Okay, good. Mania, do you have questions?
No questions.
Yeah, so we don't have question, we just stop here. And next week we'll introduce the last one module, and then we will complete all the content for this semester, and we have final exam. I will let you know which day. What we will choose 3 days, maybe
Okay.
7, 8, 9, or 8, 9, 10. Which one is better for you? Maybe 8, 9, 10 is better for you.
Well, 8, 9, the 10th, well, I'll speak for myself. That's over Mother's Day weekend. So I would recommend, for us to
Right.
be finished with the test by the 9th, so it doesn't
7,
spill
8.
over into Mother's Day weekend.
Okay,
I
7.
agree.
Mm-hmm.
I said one. I will prepare exam, last exam, for
Okay,
the 3 days, 7, 8, 9.
thank you.
No questions from the quiz questions. Yeah. Okay, if you don't have question, we just stop here today, and see you next week.
Okay, thank you, Dr. Wayne. Have a good night.
Good night, everyone.
Good night to you too. Bye-bye. Bye-bye.